Hey guys, so last week I showed you a video of our Arduino controlling the motor through the motor controller, and this was done by sending a speed control reference from a computer over either a USB cable or a Bluetooth connection using using serial communication to the Arduino. Now, in this control scheme, all of the processing and the code was housed within the Arduino. It was done with a C code .ini file, which was uploaded onto the Arduino, and then the Arduino does all the processing. Considering the fact that we're going to be using LabVIEW, we took a step back and decided to consolidate all of our code onto a computer running LabVIEW instead. So this accomplishes two things. We no longer have to worry about keeping and managing two separate codes and keeping them in two different places. For example, we're not going to have a C code running on the Arduino and then a LabVIEW running on the main computer, and then needing to have both shake hands and do proper timing with each other. Instead, what we're going to do is we're going to keep all of the code in one file on the main computer in LabVIEW format, and the Arduino is actually going to be an instrument for the LabVIEW code. The other thing that this accomplishes is that the Arduino no longer does any type of processing. It's now just, as LabVIEW would consider it, an instrument. So we don't have to worry about timing. The Arduino doesn't have to waste time looking at its serial stack, basically listening to see if it has any type of commands. It's just going to directly receive its commands from the LabVIEW computer. So I had never actually used LabVIEW before, so most of this week was spent getting everything set up and mirroring the type of setup that we had before. So I'll show you what I have now. This might look familiar if you remember the video from yesterday. Here we have the Arduino, we have the throttle, which serves as an analog input, motor controller powering the motor, and a voltage source powering the motor controller. Also have a voltmeter plugged in so you can take a look at the voltage that's being directly sent to the motor controller, and a USB cable powering the Arduino. So the control scheme is the same. Again, it's just like a regular car. You can control the output voltage, or you can control the speed of something by manually adjusting the throttle. So you'll see here that we can turn on the motor, and as we adjust the throttle, the motor will increase and change. And then we can also send a reference value to it directly. So far nothing looks different. The hardware setup is completely the same, but what's different is that the Arduino isn't doing any of this processing. All of the processing is actually happening on a computer with LabVIEW. So this is the block diagram for LabVIEW. It's pretty simple. I can walk you through the code now. It's a lot easier instead of having to look at C code. But basically what this is doing is, this is a block, and I'm sorry, I know it's difficult to see, that initializes communication with our Arduino based off of a baud rate for serial communication and the port with which the Arduino is connected on my computer. This big square is a loop, so it's just a while loop that's constantly true, and the while loop will stop at any instance where the stop button on the HMI is pushed or there's an error with the Arduino. We have an input field that lets you define which analog pin you're wanting to do an analog read, and this block right here is an analog read. This loop on the inside is a case, or pretty much an if statement. And again, the logic that we're employing here is, if the throttle is being used for control, then, send the PWM signal that matches the throttle input. If you have a reference that's a reference command or a command speed that's being sent to the Arduino, then use that reference speed, unless you have a voltage or a throttle command from the throttle input. So same logic as before, but now we're doing it within LabVIEW, and LabVIEW is doing all of the processing and just using and sending the control commands to the Arduino. And this is the user interface. And I know this is blurry, I'm sorry, but this is the meter that's measuring the voltage that's being sent to the motor, and this is the voltage that's being measured on the throttle input. So I had mentioned this before. The throttle input likes to hang at a value slightly more than 1. I'm sorry, slightly less than 1. And then this is the input field to manually send a speed command. So, like we did last time, we can send it a value between 0 and 255 because that corresponds to 0 and 5 volts on the PWM. So I'm going to send it 127, and when I do that, that's the halfway point, and you'll see that the output voltage gets sent to 2.5, which is the halfway point here. Fortunately, the motor didn't turn on. I've been having an issue where the motor, I don't know if it overheats or something, but it'll turn off. It just needs to be unplugged and plugged back in. But what you can see is the output voltage. So this is the reference voltage being sent to the motor controller, and you can see that it actually does go close to 2.5. Again, you can actually send this to 255. You'll see the meter goes all the way over, and you'll see that the reference voltages that we're sending to the motor is almost full speed. It's around 4.74 volts. And just like before, if we were to put a throttle input to it, the throttle input will take over, and you'll see the bottom right now matches exactly what the throttle input is instead. And that's it.